Welcome everyone, and thank you for coming. Today's presentation will be a browser testing framework for the LHG group. My name is Trevor Woerner, and right here is Chen. Chen is our Fujitsu assignee. Chen actually did the bulk of this work, and it was my job to then be his reviewer. I reviewed the document he wrote, looked through it, offered some suggestions, whatnot. I wrote an OE recipe so that this framework that he's put together would be easy to add to images for testing and whatnot, so try to make it as easy as possible. And this talk is to basically go through sort of what this test does, what it covers, a little bit of how to use it, and hopefully it's easy to use and to get some feedback and see what you guys think of it. When I joined the LHG group, I wasn't aware of this, but when you're looking at the channel selector, for example, on your favorite set-top box, you're actually looking at a web browser. And then, of course, when you actually play a channel, then, of course, you'll get some full-screen GStreamer, accelerated, fancy stuff. So it's very important for set-top box developers and product managers and whatnot to know how well the browser is performing. And of course, nowadays, users are always looking for fancy, cutesy tricks, and they want nice transitions and whatnot. They don't want jerkiness. So it's important to know, how different browsers are performing on different platforms and with different technologies. I mean, if someone wants to experiment with replacing the web browser from WebKit to, say, Chromium Embedded Framework, is that going to be an improvement, or is your performance going to go backwards? So it's always important to know what your changes, how they're affecting the user experience. And the easier it is to automate this, then of course the easier it is to test it. You don't want to have 10 people run out and have to spend 3 days testing it. It's nice to be able to hook this into a CI loop and basically get a sort of smokescreen, a feel for whether today's changes or the most recent change is improving or making things worse. So the outline for today's talk, we're going to give an overview. We're going to talk about the test categories and what different tests are available, and look a little bit at some of the outputs. Yeah, it's also important, in order to make it easily scriptable and easy to run, you want to be able to run it in something that's easy to add to your image, most likely using stuff that's probably already in your image. So if you're doing Linux development, chances are you have some sort of shell, hopefully bash. I don't think there are too many bashisms. It probably wouldn't be too hard to get rid of any bashisms. But anyway, so all that's really needed is Python and a shell. And then as part of the framework itself, it wants to do some tests. So it needs the files that it needs available in order to do some of its tests. But in terms of execution environment, as long as you've got Python 2.7 and a decent shell, then you're fine. There are currently 6 categories of tests that are done: sites, layout, image, rendering, JavaScript, HTML5. And then at the end, you basically get a big number that's in milliseconds. So the smaller that is, the better. As I've mentioned, some of the advantages, there were different test frameworks that were examined, and what we were looking for were things that could be automated easily, things that could be used on both a Linux and an Android platform, since the LHG is concerned with both Linux and Android platforms. We want to make it incredibly easy to add cases, test cases, and browser configurations. And so it's very easy to add different cases, and then to those cases to add different suites. So you can expand the tests in any direction you want. We liked this one because it has high test coverage. Things like HTML5 and JavaScript are absolutely necessary. You can't, I don't know that anyone's going to be creating a set-top box that doesn't have that sort of stuff. And it's important to be able to load things that are really being used out there. Static HTML just isn't going to cut it. Yeah, and then we've also added things like 4K images, and someone wrote an HTML5 game that you can run right in your web browser. So there's actually a test that we've added for that. So the different categories. The first one is sites. We don't want the test to be impeded by your network connectivity. So the framework actually downloads all the necessary files it needs to the image so that you can load things like Taobao, Facebook, and a whole bunch of others, and just verify that those can load properly in your browser. And of course, that's all kind of stored offline. And then with the layout category, we're looking at some static and CSS, but also things that are dynamically controlled with JavaScript. The image category is involved mostly with rendering and layout to make sure that things stay where they're supposed to and don't bleed into other regions. The rendering category is more graphics intensive. It looks at, it runs a bunch of tests that will really sort of drive a bit more of your graphics to make sure that the rendering engine is working properly. And then of course there's a separate JavaScript test which will have more complicated JavaScript to make sure that the JavaScript facilities available in your browser are actually working properly. It's quite interesting, actually. In a future slide, I actually mark the RDK emulator as yellow because back then, when we first put these slides together, the JavaScript portion of the test wasn't working in the emulator. But as I was running the test earlier this week in preparation for this talk, I realized that the JavaScript tests were suddenly passing in the emulator. So it's certainly doing a good job of testing those things, and the slide isn't updated, but these different categories, things can improve. And then HTML5, I mean, obviously it's the way that everything is going today, and so being able to know if you can support HTML5 is going to be an important thing for LHG members. So running the test, running the test on Linux, like I said, a browser, Bash, and some Python. You get the test suite onto the device, and you can run it from the command line. It's quite easy. This is a bit small, but the slides are online. There's only, you're invoking a shell script, and then you're invoking this driver.html, and then you specify your browser. So there's basically only three parts. You're specifying which, you're starting a shell script and specifying where it's going to find its files and then telling it which browser to run. So if you're running the test on your Linux desktop, then of course you could use Chromium or Firefox or Conqueror or whatever you want. And then if your browser requires special configuration in order to get it to work well with this test, then you specify those afterwards. So although it looks like a long command line, it's quite simple when you break it down. You can add extra options on the command line to say just run the JavaScript tests or just run this one JavaScript test, for example. But that's all documented in the document that Will wrote. But for a simple case, to just run all the tests, this is all you really need. And then on Android, you need to establish an ADB connection, as you probably would be anyway if you're doing Android development. and it installs and can be tested automatically. And it's virtually the same thing. You call a different script for the Android tests and add any options that it needs. In fact, it's a little bit simpler on this case, but quite simple and easy to control automatically. So here's that slide I was telling you about. Colors aren't too clear here, but this one actually here, the RDK emulator is actually yellow. That can be updated now to green. You know, we ran the tests on the desktop, on various desktops. They all run great. And then in some of our member boards. Here we have 2 Linux-based member boards, the High Silicon board. And, well, actually, this one here is actually the RDK emulator that's created by Comcast running within VirtualBox on an x86 machine. And it's an x86 image, but it's capable of running these tests as well. And then this last one here is the Woerner A80 board, which is running Android and is able to run all the tests. Now to look at the output files, we got a bunch of different output files. A bunch of them are all text-based, such as this sweetscores.out, allscores.out is also text-based, and then there's category files, which are text-based, and category out. And then there are also HTML files. So again, not only is it easy to run the tests automatically from the command line, but to collect the results is also quite easy too, because if you just want to write some kind of parser for plain text, then you can do that, or you can run some sort of XML parsing over your HTML output, so whichever one works, but it's all quite easy. And really, if you look at the last line of the text files, it basically gives you that big number in milliseconds, and so we can see that in this case, the Firefox browser ran these tests a little bit better than the Chromium did on this particular setup. And then this is how it would look in HTML. So that's the end of my slides. I am going to start the demo. I'm going to show you the tests running in the RDK emulator. And if anyone has any questions, then feel free to ask.
So I have a question.
Yeah.
So I see that this test was running on Chromium version 37. Have you tried to compare it with different versions, newer versions? What are the differences, improvements between versions?
Oh, sorry.
So my question is if you have a comparison of benchmark results across various versions of Chromium. So this was Chromium 37, let's say 38, 39, or if there is an improvement. And also if you have any results running the test cases on RDK and Chromium at the same time.
Do you want to take that? I think at this point, well, for me anyway, the point was to prove that it would work across different platforms, across different browsers. Running the tests in a Chromium on a desktop, I don't think is too important for the members necessarily. So we saw it worked great. In fact, getting it working on those was just really my attempt to get more familiar with the framework and play around with it in an easy environment before starting to use it on member boards and stuff, which can be a little bit trickier. So I don't think the point was actually to care so much about how the different Chromium implementations were comparing against each other on the desktop. At this point, we needed to find a framework that would work on all our current member boards, both Linux and Android, and make sure that they all pass. And then once we have that, then we can start saying, okay, you know, is it better here, is it better there, which board's performing better, which which guts are WebKit, Chromium embedded, which ones are working better. So I don't personally, I just have those results that we showed. I didn't keep performing the test, every time a new version came out. I just kind of did it once and said, okay, good, it works, check, next one, please.
So this benchmark cases is developed by Linaro by yourself or integrate other third-party benchmarks?
So the question is, did we create the benchmarks or was it created by someone else?
Yeah.
Will, that would be a perfect question for you to take.
All these test cases are collected from the internet,
Okay.
but all these are free to use in the multiplication.
Okay.
Yes.
Okay. Thank you.
Yeah, if I can add one point.
Grab this. Send it on.
It's really like as the title suggests, a framework. So we have a collection of benchmarks that we've added, and as Trevor showed, it focuses on sites, other areas, and so the way the framework is set up, like a test harness, you are free. Then if you find another benchmark that's cool and you want to add it to the test suite, you can do that, and it just gets run in the script as well. So it's really like a harness framework. And so it was originally code or a project that was given to us by one of the members that they had developed, but wanted to see it kind of improved and then kind of given to Linaro. And so now we're going to give it to our QA department. And so we'd like this to be used more widely across Linaro.
Okay. So for me, is it easier to integrate my case to the framework? Is it easier to add it? Okay.
Yes, it's easy to extension.
Okay. Thank you.
So I have a question. Yes, this is kind of, the performance management is kind of time, based on time, right? Do you have a method for measuring, for example, we scroll the screen, zoom in, zoom out? So if you look at the telemetry, for example, they have instrument for the measure these the UI operation like scrolling and zooming. So it's not just the time elapsed or the FPS.
At this point, someone still has to watch the test at least once to verify that it actually is executing properly. And someone has to check the results. We don't have anything now that will, say, take snapshots and verify that at this point what's on the screen is what's supposed to be on the screen. Right now the framework is just based around time, and but it certainly is something that we've definitely talked with members about adding that sort of capability. So.
Yes, I think the technical difficulty is that you probably need to implement or design some, instrumental method in the browser. Chrome has their own way, but I'm not sure Firefox supports it. But as I know, Kui, the there's a standard, right? Kui, there's a standard for the instrumenting for the performance.
Do you know what it's called?
So performance, you should add some plugin or hook to for example, when you scroll the page, there's some browser specific support to measure the performance.
I think he said that, for example, the telemetry provides the results such as the input latency when you're scrolling the pages and the first gesture in, latency. So personally, the telemetry is friendly to developer. You can analyze the bottleneck according to the, for example, the mean rendering time, for example, and the janky time, yeah. So and my question, another question is, when you execution benchmark and if you found the performance regression, will you fix it or create bugs to Chromium or Google?
Well, certainly if a member, like let's say a member had just upgraded from one version of Chromium to another and they noticed a regression, then it would be up to them then, at least they would be aware of the issue, for example.
Yeah,
and that's
yeah,
an
right.
important step. And then they might decide in their product that they will stay with an older version, you know, if they can, if there aren't security issues or any other business reasons why they shouldn't. Because certainly performance, user experience is usually quite high, is quite important. So yeah, this is just giving them the data that they need so that they can then decide what's going to provide the best user experience.
Okay, so you will try to root cause the regression.
Yeah, and there's been so much fluctuation in the browser market now. You know, WebKit is kind of out, and Chromium is, you know, the new kid on the block. And so a lot of our members are saying, should we switch? Do we want to switch? What graphics frameworks, which libraries should we use? Should we use OpenMax? Should we not? You know, and they don't have the data readily available to say, is it better with OpenMax or not? You know, so that's what we're trying to help provide them with this framework.
Okay, thank you.
Yeah. Do you have a question?
No, actually it was answered. The question was that, can I add? No, the question was same. Can I add third-party test cases into this framework? There's many third-party, so I think it's already answered.
Yes, if the third-party test case is free to use in the distribution.
But will this framework also give me, because you brought a very interesting point about OMAX. So for example, if right now in these test cases in the browser, you also have video test cases, means we play the video in the browser through some through some URI, and then check that how the frame time, how it's coming, or how the video is playing with all the different parameters with respect to different browsers. Is there some sort of extension is there?
Yes, there are like rendering operations that you'll see. And for example, it's listing off how long it took to render this image that we're looking at right now. You know, if there was more acceleration occurring, then that image would come up faster and that time would be shorter then, you know.
But I don't think for video it's the same thing. Like if you have like a frame, you know, if you're playing a file and there's a frame drop or you go to a lower FPS, we're not quite set up for that level yet. Well, is that true?
So this test case is basically exercising the browsers from top to bottom. So it basically exercises the top layer of the browser, and it doesn't have low-level hooks to, you know, benchmark kernel level or display level or DSP level properties and variables.
Yeah, that I understand. Only thing is that in this benchmark, for example, if we, as a framework, because this browser will not only use for the display rendering all our graphics, but also we will use this browser also to play the video, right? Now my question is that if I take the same URI and play in different browsers, so like at least we know that I click and I know that my video is playing, so the time, right, to take to do that. Of course, the hardware will also be involved in that. So it's just not just a browser time. But overall, is there any way we get such data, or will it be useful? Just a thought came to the mind.
Well, correct me if I'm wrong, but I don't think there is an easy way to do this, because if you have, a 5-minute video and it plays in 5 minutes, it still doesn't tells you if it was played in a good quality, not how many frame drops, audio drops, or whatever happened during that time.
All right. Well, thank you, and enjoy the rest of the show.